Hello everyone, this is group 7 and this is our title of our project is simulation of radio surgery using a robotic arm. You can see this is our model of a robot arm which has a 6 degree of freedom. This is our first joint, which is first servo. The second joint is this one. Third joint is controlled by this servo, and the third joint is over here. You can see this is our third joint. This is our fourth joint, which is a revolute across this, and this is a fifth joint, and this is a sixth joint, which is we are not using this sixth joint, but these are just controlled by a fifth joint. And instead of a radio surgical gun, we are using a laser over here, which is automatically controlled by an Arduino. And this is our breadboard, in which we have used a connection. These 3 capacitors are used for just making a stable running of our servo motors, and the entire servo motors are powered by a artificial DC power supply, in which 5.8 volts, that is approximately 6 volts, and 2 amperes of current. And we have, as you can see, we have just programmed the entire working of our robot using a MATLAB programming. This is our program. You can see this is our program. Okay guys, you can see this is a GUI which we plotted, in which 3 axes are there, in which one axis will be for the original image, and the second axis is used for the extraction of tumor, and the displayed image will be displayed in the second axis, and the third axis for plotting of the robot. This is the panel for selecting 3 images, which is sagittal, axial, and coronal. This is the panel is for extracting and capturing the values of X and Y, and this is the push button for plotting the robot and activating the main robot. Now I am selecting the first image, which is a sagittal image. As the image is getting loaded, I am selecting a tumor part, and the extracted tumor part is displayed in the second axis. Now I am selecting the X and Y values and capturing the values. You can see this is the approximate value of X and Y, which is around 201, 211, and Y values are 188. So now after plotting the robot is getting plotted in the third axis, and you can see our robot is targeting the tumor in the exactly 5 different orientation. And you can see that in this picture you can see the robot is moving in different orientation.
Now let's go to the third image. Lower image. Now let's extract the tumor. And let's plot a point on it. And let's capture them. These are the new X and Y values of the tumor. Let's plot the robot now.
Now we're gonna do image 3. After we load the image, we choose the point, then the processed image is loaded, then we choose the point. X, Y, Z, we get X, Y, we got it now, then capture, then plot our robot. Then we are done now. As we see, the robot will go to the target, and the laser will point to the tumor in 5 different positions.